All right, this is still 2/8. This is kind of like the second part of it. It's very, very similar to what we did today, except, well, what we did yesterday, we went over the homework today. Except we had all equals today, didn't we? So what do you think we're going to have now? The sigh of, oh man. Yeah, we're going to have inequalities, right? All right, so we're going to do basically the same thing, but inequalities. So absolute value with inequalities is what we're doing. So it's 2x plus 1, and then less than 7. Right? It's really not any more difficult, I don't think. You just have to change one extra thing. All right? Do you remember before when it was equals? The first one we wrote it exactly the way it was, right? Then the second one we only changed the right side, no big deal. But this time we're going to do the same thing, except the second time around, right? When you change this to be a negative, you also got to change something else, and that's really the only thing. Yeah, you just got to change the direction of this inequality, and that's basically it. That's the only thing different between yesterday and today's lesson. All right, so we're going to write two different inequalities down. The first one looks just like this, except we get rid of the absolute value symbols. All right, so I've got 2x plus 1 is less than 7, and I'll solve for x here in a second. Okay, but then we got to rewrite it a second time, so it's going to be 2x plus 1. Now, that's right, we change the inequality, and you change the sign to a negative. Everybody see that? All right, so make sure that you do both of those things. Look, I changed the inequality, and I changed the sign of that number on the right. Make sure that you do that. So let's see what we get. Subtract a 1, so that's 6. Divide by 2. Now I just divided by a positive 2, so I don't change that, do I? And that's just a 3, so x is less than 3. What about this one right here? We're going to write this as interval notation also, okay? So we got to add a little bit of extra because of the inequality. So let's subtract a 1 from both sides. So 2x is greater than, subtract a 1, which would be negative 8. Divide by a positive 2, so again, we're not changing this. So divide by 2, and that's negative 4. So let's see what we have. Let's graph the thing. It makes our interval notation a little bit easier to recognize. And what do we have? We got negative 4, right? And we have what? Positive 3. So make sure you put them in the right spot. So it's less than 3, and it's what? Greater than negative 4. So it's parentheses here, right? And parentheses here. And guess what? Everything shaded in between. That's right. So everything's shaded in between. I'll make that a little bit thicker. Alright, so there's our graph. So how would we write this in our interval notation? Parentheses, negative 4, comma, 3, parentheses. So that's how they want you to write your answer, just like that. Make sense? It's not hard at all, is it? Because we already know how to do this stuff. That's not that big of a deal. Really, the only thing that's different about this is changing the direction of the inequality, right, compared to what we did yesterday. It's really the only thing different. That's why I could have probably taught this in one lesson, but I split it. And my whole plan was to split it. I didn't even know we were going to run short on time yesterday. But all right, let's see. You want to do another one? Good. Let's do another one. This looks like it's the same thing, but it's a little bit different. What's different about this? Well, the other one added absolute value. This is greater than this time. The other one was less than, wasn't it? Isn't that the same exact numbers? Yep, same exact numbers, except the first one was less than. This one is greater than. Let's see the difference in this. So, yep, 2x plus 1 is greater than 7. Then 2x plus 1 is less than, right? Change the direction, and then negative 7. So let's do this. Subtract a 1, so that's 2x greater than 6. X is greater than 3, right? So remember, before it was less than, right? So look at this one. Subtract a 1, that's negative 8. So 2x is less than negative 8. Divide by 2, x is less than negative 4. So let's... Now, you don't necessarily have to graph it. If they don't say to graph it, you don't really have to. But I think, personally, it makes writing it in interval notation a little bit easier, don't you? So I've got a negative 4 here and a positive 3 here. And so what do? It's less than negative 4. So Where's my parentheses going to go? In the left direction. Do you see how it's pointing in that direction since I'm going to the left? It doesn't point, it doesn't like open up to the right, does it? It opens up to the left because it's less than -4. And it's also what? Greater than 3. So this is going to go towards the greater. Do you see it? They don't point in towards each other like they did before, because this goes to the left, this one goes to the right. Okay? And I mean, you don't really have to technically finish off this graph right here, but I'm going to just to make it look real nice. Okay, and then alright, so what did I just do? Oh, I know what I did. Forgot to change it to. There we go. Alright, so that's what it basically looks like as far as the graph is concerned. So how do we write it in interval notation? We go from where to where? From -infinity to -4. Now it's always open there, and in this case it's open here as well, right? Because it doesn't say or equal to. And then it's union with what? 3 to infinity. And it's open on all accounts, isn't it? So this is how they want you to write your answer, just like that. You don't really have to graph it unless they ask you to graph it. They could ask you to graph it. I don't know if they do. Somehow I don't think they will on these. Okay, they'll probably just ask for the solution. This right here is the solution to this inequality problem. Alright? Let's try another. They call these special cases. Alright, let me see. Alright, look at this. This is actually, these are special cases. These are, you know, the one we just went over as far as no solution. You could kind of just look at them, right, and tell that there was no solution because you can't have a positive equal to a negative and all that kind of stuff. Well, this is kind of works the same way, a little bit the same way. Let's take a look at this. So look, no matter what number I put in for x, what is this left side always going to be? Because it's in absolute value. It's always going to be positive, isn't it? So it's always going to be positive. Look at this. Is a positive number always going to be greater than or equal to -4? Look, because this is always going to come out positive, right? So even if I had a tiny little positive number, like 0.0001, is 0.001 greater than or equal to -4? It's not? Yeah, it's greater than -4, right? 0.001. Any positive number is going to be what? Greater than -4. Name me a positive number that's not greater than -4. You can't. -2? That's not a positive number. I said name a positive number. Listen, you got to focus. Name a positive number that is not bigger than -4. You can't. Because you can go 0.000000001, right? That's still greater than -4, isn't it? Alright, you can't give me a positive number that's not greater than -4. Got it? Alright, so what is the answer here? Is it no solution? It's actually every single solution in the world. Alright? Doesn't matter what I can pick for x. I could put anything I wanted to in for x right here. And this will always be positive. A positive number is always greater than -4. Now, it's greater than or negative. It doesn't say greater than and equal, I'm sorry, greater than or equal, right? It doesn't say greater than and equal to, right? It says greater than or equal, right? So every positive number will either be greater than or equal. Now you know the or equal is not going to work out, right? Because a positive can't be equal to -4, but it does fit this. All right, so every single possible solution. How do we write every single possible solution? Think of the number line. Just infinity, just going to write infinity? From where to where? From -infinity to positive infinity, right? From -infinity to positive infinity. That means what? Every single possible number on the number line. Would you agree? And that's in an interval notation. So that would be the answer to this problem right here. So every once in a while, before you actually start doing stuff, right? Making two sets of inequalities and solving for x. Before you do that, take a quick look at it and think about it for a second before you start just plugging and chugging. Alright? Make sense? Let's try another one. What about this one? This is another special case. Remember, we want to take a look at it first and think about it before we start plugging a whole bunch of stuff in. What about this? Again, what kind of number will this always be? It's always going to be positive, isn't it? All right. So this will always be positive. Say it. No solution, right? Can you have a positive number that's less than negative 3? No, because every single number less than negative 3 is going to be negative. Can you have a positive less than a negative? No, it's impossible, right? So are there any numbers that even work for this? No, there's no numbers that work for this. So what do we say? We say null solution, or you can write null set or whatever. If you don't want to write the words out, no solution, it's fine with me. All right, any way you do it. This is kind of a quick little easy way to write it. You got it? So these are kind of special cases. We didn't have to do any math at all. All we had to do is look at it, understand about positive numbers and negative numbers. They give you one more. This really kind of, I don't know, this is kind of self-explanatory. I don't think this is really all that special, to tell you the truth. But they put it in here as one of our special cases. All right? What if you had this? Well, normally what would we do? We would set this equal to 0 and then set it equal to what? Negative 0. But is there such a thing as negative 0? So, no, really. So all you really have to do is what? Just set this equal to 0. Agreed? Because you can have the absolute value of something come out to be a 0. It can't be a negative, but it can be 0, can it? All right? Because remember how we always said it always has to be positive? It's not always true, okay, with one exception. This could come out to be a 0. All right? So the absolute value of 0 is 0. Follow me? All right. So what's going to make this thing into a 0? Yeah. Subtract 15, divide by 5, so x is negative 3. Negative 3. All right, so if I put a negative 3 in for this, 5 times negative 3 is negative 15, plus 15 is 0. What's the absolute value of 0? It's just 0, so 0 does equal 0, it works. I don't know if I would consider that one a real special case. The other two I definitely think are, right, with no solution or infinite solution. But there you go. All right, I think that's all I'll do for this. It's not too hard, is it? So I'm going to give you worksheet section 28B. All right, so that's what's going to be due tomorrow. All right, that's it.